Hello YouTube. What I have today is an HP server power supply, 750 watt platinum rated. The model number on it is HSTNS-PL29. And the issue that we're experiencing today isn't with the power supply itself, but it's actually with the breakout board that's connected. The power button has become unresponsive. And through troubleshooting, what I've determined is that the latching mechanism or the latching circuitry that is built into this board has failed. So rather than repair the board by repairing the latching circuit, what I'm going to do is simply install a on-off switch coupled with a resistor. So I found my information through an RC car forum that apparently they use these for charging LiPo batteries. So they provided the pinout, and what you have to do is jumper across pins 33 and 36. As you can see, the power supply will now turn on. So you could solder this directly onto the leads, but what I'm going to do in my case is solder on an on-off switch so that I have the ability to actually turn the power supply on and off. So I'm going to go ahead and solder that in, and I will show you the results. So here's the push button switch that I have soldered the resistor in line with. That's again 330 ohm resistor. Different power supplies may require different resistors. I've seen where some use 1,000 ohm resistors, some will use just a direct short across the pins. And in this particular case, a direct short across the pins did work. But I'm going to add the current limiting resistor just for precautions. I've gone ahead and added some heat shrink tubing to cover over the resistor and the soldering that I did. Then I'll add a second piece of heat shrink to keep both wires kind of tied together. Again, any of these repairs that we are shown here are to be done at your own risk. I'm not responsible for any damage you do to any of your equipment. This is just what I found has worked for me and thought it would be helpful to pass it along. Okay, so my repairs have been complete. I've soldered again on this particular power supply between pin 33 and pin 36 on the breakout board itself. And now we can see that with the switch, turn it on, and the breakout board powers on. Turn it off, and the breakout board powers down. So it's simply what we did here was bypass the latching circuit that is built into the breakout board. This is will be a more reliable solution. There's less things to fail in it. The latching circuits tend to be used because it's cheaper. It's than buying a couple dollar switch to install for the board. They also did it for reasons such as you could connect multiple boards together and have them power on and power off together. But unfortunately in this case it was less reliable. So I've just added a manual on-off switch. If you wanted to, you could take it a step further. If you wanted to have the ability to remote power this device on and off, what you could do is install a 12-volt relay, connect that to a 12-volt power supply, and then connect that to a smart switch, power that smart switch on off, and you would be able to power this device on and off remotely. So in this case, I'm happy with being able to just power it on and off locally, and I hope this helps you out. I'll leave the part number stuff in the link below, or in the description below, along with the pins that I soldered and the parts that I used. So hope this helped you out, and you have a good day. Bye.